Welcome to Spring LIB.
Okay, let's draw the circuit diagram first. Capacitor 1, capacitor X, capacitor 3, and capacitor 2. So C2, C3, point A, point B, C1, and Cx. And okay, now the C1 and Cx are in series, C2 and C3 are in series, and these two series pairs are in parallel. So potential difference across C1 and Cx series is same as potential difference across C2 and C3. One more information that is given is that VAB, that is potential difference between point A and B, is 0. That means point A and point B both are at the same potential. This implies that potential across C1 is equal to potential across C2. Similarly, potential across Cx is equal to potential across C3, because if potential across C1 is same as potential across C2, then the part of V0 is deposited equally among C1 and C2. Hence, point A and point B will be at the same potential. Now, let's take an advantage of the given information. Now, since C2 and C3 are in series, you can find the net capacitance of capacitor 3 and capacitor 2, which is equal to C2, C3 divided by C2 plus C3. Now, if you substitute those values of C2 and C3 given as 18 microfarad and 4.8 microfarad respectively, you get the value 3.78 microfarad. Now, you can find the potential across VC2, which is equal to Q divided by C2. Now, what's the value of Q? Q equals C23, which is net capacitance, times V0. This is the charge deposited across C2, C3 series circuit, which is equal to 3.78 V0. So let's use that to find VC2. VC2 is equal to 3.78 V0 divided by value of C2 is 18. Now similarly, we can find VC3 is equal to 3.78, because in series you have the same charge distributed on each of the capacitor. So each capacitor in series gets the same charge. That's the property of series circuit. So instead of 18 now, we have C3, value of C3, which is 4.8. Now we have VC1 and VC3. Now, as in page 1, here you can see VC1 is equal to VC2. VC1 then equals, the value of VC2 is 3.78 V0 divided by 18. 3.78 V0 divided by 18. Now, what's the value of VC1? That can be given by charge deposited on C1 divided by value of C1, which is 8.9, equals 3.78 V0 divided by 18. You know what? Let's not write the value of C1 yet. Let's keep it as C1. 3.78 V0 divided by 18. This gives you Q equal to 3.78 C1 V0 divided by 18. Okay, what's the use of the value of Q? Since we know that capacitor C1 and C2 are in series, so they both have same charge deposited on them. So I can use the same thing, same charge for Cx capacitor. Now, charge deposited on the capacitor Cx is given by Cx times potential difference across the capacitor Cx. Now, to use that information, we need to find out the potential across Cx. As mentioned before, Vcx is equal to Vc3, and value of Vcx is Vc3. Now we can make use of that. Since charge is given by Cx V, Cx Q. Now we know Q, which is equal to 3.78 C1 V0 divided by 18 equal to Cx, the value of Vc3 or Vcx is given by 3.78 V0 divided by 4.8. Now you can cancel V0 on both sides to find out Cx equal to C1 times 4.8 divided by 18, which is equal to 8.9 times 4.8 divided by 18. So this is equal to 2.37 microfarad. I hope you understand this.